All right, good afternoon, everyone. Thank you for joining us today for our concrete production facility environmental requirements webinar series, the second part on water management. My name is Oliver Zhao. I'm the technical services engineer at Concrete Ontario. I'll be the facilitator and moderator for the questions today. And just to walk through a few housekeeping items, this presentation will take about 40 minutes with a Q&A at the end of each section. All the participants will be muted during the presentation. If you have any question, please feel free to type in your question into the question box underneath. And the webinar will be recorded and also posted on Concrete Ontario website with a PDF copy of the presentation. So feel free to forward that link to anyone that might be interested or rewatch the recording. So just to present you our speakers today, first of all, we have Colin Evans, Land and Environmental Director from CBM Ready Mix and St. Mary's Cement. And you also have his contact info in case you have any questions. Next one will be Dylan from GHD Limited. He's the Senior Water Resources Engineer and Associate at GHD. And he will be also talking about the water side of the requirements. And lastly, we'll have Savio De Souza, CEO and Senior Principal Engineer at BridgeCheck Canada. He has over 20 years experience as an approved auditor of Concrete Ontario on plant audits. He will be sharing with you some key points that you guys should know about water requirements for the environmental portion of our audit program. So without further ado, I'll turn the slides to Colin.
Great, thank you. Thanks very much. It's a nice rainy day for this water management. You might be able to hear the rain pounding on my roof just above me here. We have a steel roof, so it sounds like I'm sitting in a train station right now. But anyway, thanks for joining us. I'm just going to review, some of our experiences with water management. And then Delan, who's the true water expert, will go through some of his stuff for stormwater management. This thing switching. Hey, Oliver, I don't think it's switching. Oh, there we go. So water, it's an industry issue. Water is a major industry issue right now. There is increased focus by regulators on ready-mix plant water, especially within cities and that sort of thing. Ready-mix, as you know, ready-mix production water contains solids. So total suspended solids, what they're looking for, and it also has a high pH. That's one of its signatures. To mitigate issues, water management is required on site, which we can get into. And water management consists of recycling it, discharging it, or disposing of it, and there's components of that we can discuss. One of those components is discharge requires treatment and permits and treatment, either one. Treatment systems tend to be expensive and complicated, and permits are expensive to get and difficult to comply with. There's a lot of different conditions on them that maybe people on site just may not be able to deal with. Just a couple of examples, or a few examples here, mostly American, but some of the industry issues. A company called Shea Concrete Products agreed to pay $57,000 to settle allegations of illegally discharging industrial stormwater into wetlands. A couple of companies in Guam, environmental violations for stormwater discharge. Failing to obtain a permit, notice of violation for another company arising from mining and processing of rock, sand, and gravel in the manufacture of concrete. It didn't meet its limits, so then again, those conditions that are hard to deal with, the total suspended solids. They discharged water that exceeded it. In a complaint against another company of the Clean Water Act states violation at its site. It discharged processed waters and stormwaters without the proper permits, failed to implement best management practices like we'll talk about today, to minimize stormwater that ran off the site during rain events. One of the quotes was, stormwater runoff and processed water discharge from the sand and gravel and ready-mix concrete industry are a significant source of water pollution. And that was the regional administrator of the EPA. The regulators that we're dealing with, the MECP and the municipalities, both will conduct inspections. So you could see either one of them at your site. The municipalities will issue notices of violation for non-compliance with parameters. And when you do have an exceedance with those parameters, the city bylaw, that sort of thing, they're treating it as a spill now. So they may come in and do some sampling outside your gate, find that you exceeded, and they'll tell you, they used to tell you, oh, you've exceeded, you got to do something. Now they're telling you, you've exceeded it. Why did you do it? Please, notify us. And like it's a spill, notify the MOE, that sort of thing. Regulators, as I said, they'll do compliance inspections. If they come into your site, they're going to be looking for some certain things. They're going to see that, they want to see that you're familiar with the regulations, the MECP, Ministry of the Environment. They're going to, whether you're familiar with the EPA and the OWRA, which the OWRA is the big one, the Ontario Water Resources Act. And the cities, the municipalities are going to be interested whether you know about the sewer use bylaw. They're going to want to look at your practices, your policies, your procedures, your spills plan always, and your housekeeping. They're going to take a walk around, see how you're doing. Some of the permits they might look at are called environmental compliance approvals and permits. Releases to air will be a section 9 under the EPA. Releases to water will be a section 53 under the OWRA, or the discharge C of A, or the sewage C of A. You'll see those names. Also a permit to take water that you might need if you take greater than 50,000 liters a day from a water, or from a well, or from a pond, or from a lake or something like that, not from the municipality. They're going to look for documentation, compliance records that you're dealing with your permits. As I said, when you get a permit, there's a lot to keep up with it. Monitoring and reporting requirements, maybe annual reports, and then things like you should keep discharge logs, sediment logs, dust logs, HWIN manifests for waste tracking, provincial reporting, whether that be through the WTRS for their daily water takings from your permit to take water. One of the key permits that I discussed was the Section 53, or what's called the industrial sewage under the Ontario Water Resources Act. And the basics of it is Section 53 says, no person shall use, operate, establish, alter, extend, or replace new or existing sewage works except under in accordance with environmental compliance approval, or an ECA. So that's the meat and potatoes of it. You can't do any of those things unless you have a permit. But it's a sewage works. What the heck's a sewage works? We don't have sewage. The sewage is a drainage, stormwater, commercial waste, and industrial waste. So definitely your production water gets into that. And the works are any collection, transmission, treatment, and disposal, or any works for that. So if you've built something that can discharge your production water or stormwater, that sort of thing, you're likely into that Section 53 ECA territory. So water management, a few things about water management on site. There's a couple of different categories of water, or a way to look at your water management. You completely water at the ready mix plant can be put into two categories. Production, as I said, production water that's been influenced by production. It has suspended solids in it. Cement, it would have cement in it, cement powder. One of the interesting ones that, and I'm going to come back to this a few times, is snow containing powder. You've operated all winter, you've had some dust, you've plowed up the snow and you pushed it over into the corner, and then in the spring it starts to melt. Well, it still has all that powder in it, and it starts discharging to the storm sewers, and then the city comes by and says, well, wait a minute, you're discharging all this high pH, what's going on? And I've seen that a couple of times. And the other introduction to the city's or the other category is stormwater. Water introduced to the site via precipitation conveying to the stormwater system. Water management, production water sources. Some of the sources of this are batch water runoff after a batch, so coming out of your loading point, truck wash water, truck water overflow. So you're filling a side tank or something and it's overflowing like a madman while the driver's inside eating his lunch. That's production water. I saw that happening the other day. Yard wash water. You're spraying it off and you're cleaning things. You just can't wash it all into the storm sewer. Equipment wash water. The washout itself. All water associated with the ready mix trucks, basically. And again, back to those snow piles containing cement powder. You need to contain these sources. You just can't discharge them because they're going to put you over the bylaw limits. Ways to stop this is to reduce the production water in the first place. So water use at the loading point. The rinse off, slump up, and fill side tanks. Do it at a contained location so you can reduce what's coming off that loading point. That contained location, there's a couple of different things, but basically the same idea. Everybody's probably got a washout, so water from the washout process is contained in the washout system. Solids settle out, water flows pumped into additional settling tanks to allow for more settling time. The remaining solids are recycled. Sometimes there's a small containment over by the loading point. The water runs out of there. You can contain it there, use it back in the plant, send it over the washout, wherever you do with it. Other containment tips and ideas to be thinking about is the yard should be graded to ensure water flows from the production sources to the containment. A lot of times you're going to grade it so that you can separate that storm water from that production water. Again, snow piles, back to that. Should be located so that melting does not contribute cement powder or aggregates to the storm system. So it's good snow management. Put it in a place where you can contain it. If your yard is graded in a certain way, well, you can contain it. It will go back into the washout when it melts. Use that water back in production. If you want to discharge, so you've decided, well, I got too much water, I need to discharge my production water. Well, you can do it. You got to, as I said, you got to get an environmental compliance approval. You're going to need some sort of on-site containment and some sort of on-site treatment, which can be complicated and expensive. So it's going to be, mainly consist of filters and settling tanks and pH adjustments, whether that's through CO2 or an addition of acid. People definitely can design something like that for you. It'll require monitoring, require testing, logging. Before you go to discharge, you're going to have to sample, send things to labs. It gets very, very complicated anymore, especially with the systems. You can dispose of the water. That's a possibility as well. Waste disposal tends to be expensive, but they're going to measure the pH of the water on every load to confirm it was above or below 12.5. And 12.5 seems to be that area between whether it's just a non-alkaline solution or it's corrosive. So you're going to have to set up a waste class with your waste generator number, or 122L is a non-haz alkaline solution, concrete water. The MECP has a nice way, they charge you for every manifest that comes in. So your tanker truck comes in, they give you a manifest, the MECP charges you $5 for that. But if it goes out with a 12.5 or greater, it's corrosive and becomes a 122C. The manifest cost goes up to $30 a ton. So you can see a load potentially being charged of greater than $1,000, and that's just the fee from the MOE for disposing of it. And there's the disposal costs, which come at 20 to 25 cents per liter for just the regular water. Standard vac truck, 12 to 15,000 liters would be about $3,700. The big tankers, 40 to 45,000 liters, could be about $9,000. And again, that's for that non-haz 122L water. If you have a pH higher than 12, then they need special equipment, and the price is going to go up. Is this switching? Oh, there we go. The other way to do it is recycling. As I talked about, you've contained all that water. You're going to want to use it, so you don't have to discharge. So you're going to recycle it back. So contained water should be pumped back to the batch plant and reused for production. It's the best possible way you can do it. Save on your water cost. You don't have to discharge. You don't have to deal with all that. You keep everything in a nice closed loop system. Yeah. Oh, shoot. It's not. It's hesitating a bit here on me, so I'm just going to take me a sec. Okay, so basically, we want to separate the production water from the storm water. You want to reduce the production water, reduce what you're having to deal with, reduce what you're having to contain, reduce what you would have to discharge of, reduce what you'd have to recycle. You want to reduce at the start, so you're not creating this production water. You want to contain what's left of that production water, and you want to recycle that production water. So this last slide for me, and then I'll switch over to Lab. But just remember, only rain down the drain. Unless you have an approval from the MECP and the municipality, you only want to send stormwater, clean stormwater, clean as it's coming from the rain down the drain. There we go. So I'll switch over to Delon, and he'll do a few slides for you, then we'll come back to me.
Thanks, Colin. So I think some of this will be a bit repeated from what Colin presented, but basically for our ready mix plants and concrete operations, as Colin indicated previously, the ministry, which by the way, they've gone by multiple names in the last 10 years. So right now they're calling themselves the Ministry of Environment, Conservation and Parks, but it's the same as previously the Ministry of Environment and Climate Change, and prior to that it was a Ministry of Environment. So who knows what the next government will want to call it, but for now it's MECP. The permit that they need if you're discharging water from your facilities, it's called an ECA, Environmental Compliance Approval, and it is for any water that you would discharge, stormwater and production water. The ministry is kind of holding a bit of a hard line on this. They're saying if you're an industrial facility and you're going to discharge water, we want to see an ECA. Or does that mean if you don't have one right now, you know, you got to give them a call and start the process on getting an ECA? Not necessarily. In Ontario, the way they kind of work it is, you know, if there's a complaint, if they happen to drive by and they see a bunch of gray color water coming off your site, they might stop in and ask what's going on, and then you can get into a process. But on paper, if you're an industrial facility and you discharge water, stormwater or production water downstream somewhere, then you need an ECA from the ministry. If you contain the water and reuse it, then you know, they are trying to get people to maybe still want to get an ECA, but it's not absolutely necessary that you get an ECA if you're reusing everything. And we try to push to not need an ECA if you can reuse everything. So obviously, from the environment perspective, but also from a permit perspective, best if you can kind of contain it and reuse it. Stormwater can go off to like any number of receivers. Typically, if you're in any sort of a city, storm sewers are connected to the city storm sewer. So usually it's on the road, and so you'll have one or two service connections going out into the sewer. And most cities now will try to put what they call a compliance manhole right at the property line. That's so that they don't have to ask you for property access to come into your property so they can sample at any time. This way they can just roll up into their right of way, which is their road. They can lift up that manhole lid technically on the property line and collect their sample at any time unannounced and know whether you're kind of in compliance or not. Other places that stormwater could go off, it could just be sheet flowing off, which is kind of not a pipe, not a ditch, but just kind of running off flat across the land to whatever, whether it be a ditch or neighbor's property or whatever. It could go off to ditches, it can go off to local creeks and wetlands and rivers and lakes. So all of those would be subject to some criteria, and that's why it's best to kind of keep your production water contained so that it's kind of clean stormwater going off, and then it generally results in less sort of heartache. If you are discharging production water or stormwater off-site, the criteria that you have to discharge to is really depends on what you're discharging to. If you're going to a storm sewer, then typically it's that municipality storm sewer use bylaw. If you're going off to a local wetland or river or creek, then oftentimes the ministry of they may ask you to do it to what's called the provincial water quality objectives, and that's pretty tight, and so that could get a little bit tricky. Next slide, Colin. So stormwater, like we said, if possible, try to reuse it. And if you're reusing it, then you could call that a closed loop, meaning water goes in, but nothing's really going off to the environment. That's sort of your best scenario. And obviously, I mean, from a cost perspective as well, most people use city water for your concrete production. But if you can reduce that by going closed loop, that would be great. Now, not to say that that's a absolutely simple process. Yeah, you might have to heat the water, you might have to do some filtering. Most people in the ready mix industry have a series of sumps and or washout tanks, and you send it from one to the other and you drop out all your solids and you can decant it off the top. And so if you can set up something like that, or you have a setup like that, that's generally the best. Any of your production water, like Colin went through, it can be from washing the trucks, it can be from your the slump up water, it can be any of the water that comes into contact with any of your product. Sometimes we get this question saying, well, what if I just dig a hole in the ground and like dump all my water in there, and it's just gonna naturally infiltrate, or we're gonna be able to get rid of it that way. Well, in Ontario, generally speaking, in a given year, you get a lot more rainfall than you would get evaporation. So I think the numbers are roughly 900 millimeters on average of rainfall we get a year. And of that, you might be able to evaporate about 650, maybe max 700. So that means if you're not getting rid of the water some other way, year over year, you're just going to keep building up water. That'll become an issue. If you just dig a hole in the ground and it's infiltrating, well, again, the ministry then becomes concerned, well, what's the water quality going to be like going to the groundwater? And does somebody have a well downstream that they're taking water out of for drinking water purposes? And could you kind of potentially impair that? So that's something that also needs to be considered. That's why I think, again, closed loop, you're not infiltrating it, you're just holding it in a concrete tank or something like that and reusing it. Colin touched on this. Typical stormwater issues for water quality are pH, the suspended solids. That's basically what makes the water discolored. And then oil and grease is sometimes something you'll find. There are some other stuff that you might find too if you go looking, like metals and other things. But generally speaking, if you can control these three things, then you're in good shape. Let's see here. With respect to how do we control things, again, Colin touched on this, good housekeeping practices. So right from the get-go, if you're doing a new plant, try to keep it so that you're paving as much of the area, because when you have gravel yards and you got that many trucks running over it every day, you're going to generate a lot of suspended solids. Even if you weren't dealing with concrete, you'll still generate a loss to suspended solids, and that gets washed off, and then it'll go off to wherever, and that's an issue. But then if you do have areas where you're doing your slump up and you're loading and unloading, those areas as a minimum should be graded to drain to your containment tanks and your washout tanks. That way you can kind of keep all that dirtiest water coming in, but it's very hard not to track it off to other areas if you site. So if you end up having a bit of a sloppy operation, then you might track it off to other areas, and then it may still not pass the test. So trying to keep your operational areas clean and tidy, contained, draining all to one area, paving the yards, those are all good ways of not addressing the potential contamination at the source. Now, if of course, not every site can you contain everything. So if you can't, then you get into all of the capturing and treatment technologies, and their filters. We'll go through some pictures in future slides, and all-grit separators and treatment systems. Suspended solids, that's basically like settling out dirt. So that's relatively easy to do, and there's a lot of techniques out there for that. pH, well, not everybody's dealing with pH issues, and it's actually kind of hard to deal with. You would think it's simple, but once you get into adding chemicals, it does get a little bit complex. Next slide. So to comply with most municipalities and MECP standards, you have to meet their discharge limits. Like we said before, the discharge limits are really based on where you're going to. If you're going to a storm sewer, then most cities have what's called a storm sewer use bylaw. Some places it's a combined sewer, so then you might have whatever combined sewer bylaw. And if you're going directly to a creek or a river or wetland, then it gets a little bit more of a gray area, because you now have to do probably some assessment to figure out, well, is it already a completely degraded creek, in which case there might be a little bit more leeway for what you can discharge, but otherwise, it could be pretty stringent. In general, for pH, what you see is somewhere between 6 and 9.5 is what you're permitted to discharge. Depends on cities. Some cities are 6.5 to 9, others are 6 to 9.5, and it goes like that. But generally speaking, it's in that range. And suspended solids, almost most municipalities have a 15 milligram per liter requirement. And just so you know, 15 milligrams per liter, that's not very dirty. Like if you put 15 milligram per liter water in a glass container and you looked at it, it's not going to look, like it's gray color. It'll be slightly off clear. So 15 is pretty tight. But that's what they're expecting people to discharge at. With respect to other measures that you can use to kind of minimize your impacts, you can reduce your suspended solids loading by doing mud mats or construction entrances. That's to kind of keep us dragging out stuff onto roadways. There are some people that'll go as far as doing wheel wash systems. And sometimes people will dig up and put in like graded trenches and try to keep it so that everything drains down to the trench. But recognize that all of these items will have some maintenance with it as well. So again, best to try to contain everything and not have it track around. But if you're going to track it around, then you could use some of these measures to try to contain it and minimize it from tracking offsite. There are other options for filtering stuff out. So at all the catch basin grates, you could put in catch basin filters. There are these other products called filter socks. Usually it's like a sock and you can fill it with whatever, but typically people fill it with like a mulch or something like that, because those wood chips do tend to soak up and prevent the sediments from getting out. And then sometimes it's as simple as in that right-hand picture there with the two cones. People just put some pieces of geotextile under the catch basin grate and then they close it. I mean, whatever you're doing, generally speaking, the cheaper solutions are going to be a bit more of a headache, like that filters cloth under a catch basin grate. Well, what happens is it fills up and gunks up with all the dirt, and then you go open the catch basin grate, all that weight is just going to pull that filter fabric down, and a lot of people just lose it right into the catch basin anyway. So if you're going to go that route, it's better to do something like they've shown in the bottom left corner. Buy something that comes in a frame where you can drop this bag into the catch basin, and then these things come with like little gaps at the top. So if you get a massive storm, it can still flow water out, so you're not going to flood. But then to lift it out, it's pretty easy. You lift it out and you place the bags. But yep, a little bit costlier, but generally speaking, works better. So that's some filtering options that are very basic. This isn't going to get you all your fine cement size particles filtered. There's a practical limit, because if it's filtering cement size particles, then it's not really even going to let water through, and it's just going to be useless. So it'll get you some improvements, but maybe depending on the site, just that alone might help you. And the next slide. This is just indicating that you do have to maintain whatever system you have in place, and we'll have some discussion around that later on. But your catch basins and manholes, a lot of sites we've been to, the catch basins are just full of gravel and dirt, and they're dealing with standing water and puddles everywhere. And that's because nothing's being maintained. So when you generate a lot of solids, unfortunately, you got to get vac trucks out and you got to suck that stuff up. Otherwise, it's going to clog your sewers. Once it starts clogging your sewers, then it's more expensive, because now you have to get a flusher truck. They have to run their jets up the sewers, and they got to flush it out, and they got to vac it all up, and they got to take that all off somewhere for disposal, because it's not going to meet clean water criteria most times. Next slide. So maintaining these systems. So some sites will end up having to need oil grit separators or other types like filters. There are these jellyfish filters. There are media filters. All of those things require quite a bit of routine inspection and maintenance. In the bottom picture there, you can see the clear plastic tube. It has a foot valve at the bottom of it. You just run it down your oil water separator. The valve opens up the minute it hits any liquid, and then the stuff just comes up into your tube. Then you start lifting it out slowly. The valve closes, and you can see how much oil you got in there, and maybe not how much sediment you have in there, but then you use a survey rod or a long pole to kind of measure how much sediment you have in there. And most of these oil grit separator units have a tolerance for how much sediment and how much oil it can hold before it's not able to clean it up anymore. So you got to do these inspections, and once it's got over the manufacturer's recommended amount of oil or sediment or dirt, you then have to do what they're doing in the top right hand photo, which is vacuuming it out. And sometimes you got to get like a pressure washer in there. Sometimes you got to do this with confined space entry, but that's what it takes if we're not able to contain it at the source and reuse it. So with these systems, you got to do the inspections, and you got to document to them that you've done the inspections. So Colin, I don't know where you found this photo, but my gosh, every time I see it, I keep thinking about, oh, here we go, 5 freaking engineers and 2 guys just working away. But the inspection logs, come up with whatever's going to work for you the best. Some people do it as high tech as having an iPad, and they've got their forms on an iPad. So people go out there, they use the iPad to take the photos. They can automatically sort of tap on whatever buttons and fill out their logs. But the other way is just the old-fashioned simple orange survey logbook that it can get wet, and you can still write on it, and you've got a logbook and you just keep track of everything. The ministry isn't going to be too fussy, or most cities aren't going to be too fussy on how you keep your records, as long as you're keeping your records, because the whole point of this thing is that we got to minimize what's being discharged off-site. So do the inspections to make sure that you know what's happening and that stuff is being managed properly, and then trigger when maintenance needs to be triggered. And that way, if somebody rolls in and asks questions, you can always produce this log and say, yep, we've been doing our inspections, we've been doing our maintenance. The frequency of inspections, the frequency of maintenance is really dependent on a site. If you have a relatively clean site, you might not have to do your inspections of your catch basins and manholes more frequently than once a year. But most ready-mix concrete sites, within a year, you've probably filled up most of your catch basin sumps and manhole sumps, so might have to be a bit more frequent than a year. And the maintenance, again, same thing, right? It really depends on how much loading you have. And so we know some sites where they probably got to clean out their filters like once every couple of months, and there might be other sites where that could be once a year. And next slide. And so, like I said, record keeping, this is just some samples of what types of forms some people have used for keeping your records. And the records you keep are really dependent on what you have installed. So, if you have just catch basins and manholes in a sewer, then relatively simple. If you end up having some oil grit separators and filters, jellyfish, or any other types of media filters, then there's a bit more to the inspection. And some of these systems aren't very intuitive. So if you do have filters like jellyfish filters, you really do have to pay a bit of attention, talk to your suppliers that supplied the equipment, maybe even have them come out and do the first couple of inspections with your staff, because just by looking down the hole, you might not really figure out exactly how that system works. And so the inspection forms are also going to be tailored to what you have installed. Some places have ponds, and you'd have to have different things in that for your inspection form. So that's just a sample of some inspection logs. I think that's it for my slides, Colin.
I think we're back to me here, so I just clicked.
Thanks. So I'll turn it over to Colin right now, and at the end, if there are any questions, obviously feel free to ask.
Here we go.
Respond.
Yep. So yeah, just to conclude my part here, I mentioned at the start that they're starting to look at discharges like that, especially in municipality, as spills. So my thought is to look at the water itself as in a spill prevention sense, and I like to use what I call what's called the source pathway receptor model, where you look at the source pathways and receptors, but apply it to stormwater management. So the purpose of this is examining your site for spill prevention. You can raise awareness of what can be spilled at the site, where it could go to affect the environment, and how it would get there. So the source pathway and the receptor, but you can apply that to stormwater. So a typical source on your site may be fuel, admixed, used oil, that sort of thing. But take a look at it like production water. So you have production water that's being produced by those sources I talked about before, or stormwater. So you have this, then how would it move if you spilled it? Do you have a paved yard, a gravel yard? Is there a swale? Something like that, or how is it moving to get off site if it's going off site? So take a look at that, figure out what that pathway is, and then what's the receptor? Where is it going to go? Is it going to drains, ditches, catch basins? Is it staying off site? Is it going to your washout, which hopefully it should be, that sort of thing. And figure out those kind of things, and then you can manage it. There we go. So the source pathway receptor for stormwater management. So it's very similar to the WHMIS hierarchy of controls. Some of you may be familiar with that. But basically, can you remove the source like I talked about? So reduce that production water, get rid of that as much as you can of that production water that's falling all over the place, so that you don't have to deal with that. Can you cut off the pathway? So again, those barriers, that containment, that sort of thing. Can you put things in the way to cut that pathway off from getting to that receptor, getting to that catch basin, getting to that swale, that sort of thing? Or then can you protect the receptor in some way? Can you put in the filters or jellyfish or the grid separators and that sort of thing to protect the receptor? So just remember that an unauthorized discharge, such as production water, could be considered a spill. Mitigation measures should be available on site to cover that sort of thing. So if you do have a spill, you're going to have your stuff there for fuel or that sort of thing. But in this case, you might want to have those silt socks that we showed, those green things there on the left-hand side, or filters or sand bags, hay bales work well, that sort of thing. All those kinds of things you can use on site to deal with it. I like sand. We all have sand. We got a loader. You can move that sand. So if you have an issue, you can use that very quickly. Oops, sorry, went too far, but if there's any questions, or we can go to Savio.
Awesome. Thank you, Colin and Dylan, for your very detailed presentation on the water management side. Maybe we can move to Savio now, and he will talk a little bit about the audit perspective on the environmental requirement, and then we can come back to see if anyone has any question. Savio?
Okay, thanks, Oliver. So today I'm going to be talking about what an auditor looks for when conducting a Concrete Ontario plant audit. First, I just want to thank Colin and Dylan for their insightful presentation. It deals with a lot of the aspects that I look for when I go to a plant. So Oliver, do I have control? Oliver, can you help me? Okay. All right, so I'll go through the checklist of what I look for as an auditor. There's two main sections to the checklist. The first is the mandatory compliance, where we look at sustainable sites. And this is either a pass or a fail option. If you pass this option, you get an Eco Green certificate. And the second section is the optional compliance. So there's 4 additional sections here, which deals with water efficiency, materials and resources, energy and atmosphere, and innovation and design. And there's a minimum criteria, a minimum percentage that has to be achieved in each of these sections in order to get an Eco Gold certificate. So there are a few exemptions to the Eco audit. If you run a portable concrete facility with its own ECA permit, then you can operate for up to 1 year at a single site. If you have a portable concrete facility, which is located on an active construction site, you're also exempt. And if the concrete plant is located on First Nations land, you're exempt from this portion of the audit. So Concrete Ontario has approximately 270 plants. 63 of these plants have Eco Green certification, 12 are exempt, and the rest have achieved Eco Gold certification. Okay, so the first section is the mandatory compliance section. The first thing I'm looking for is a site plan. So basically, it's a layout of your facility showing your stockpiles, your batch point, your washout areas, and potentially even your traffic flow within your yard. I'm looking to see if you have a corporate environmental policy. So a policy statement saying that how you protect the environment during your concrete production. So next we'll get into permits. The first permit, as Colin talked about earlier, is a permit to take water. So this is only needed if your water source is an on-site well or a surface water body, and you extract more than 50,000 liters of water per day. Then I would have to see what your permit to take water. The next permit is called an ISW, or an Industrial Sewage Works Approval. So if any of your processed water is leaving your property, then you require this approval certificate. So it should be noted that Concrete Ontario auditors are not Ministry of Environment officers. We only review the required permits. We don't enforce it or look for non-conformances in your operation. So if you have an active garage, or if you generate subject waste material on your property, you would need to get a waste generator number. So the waste generator number is also called an HWIN, which is a hazardous waste information number. So the photo in the middle there just shows a typical waste manifest. And in the top left corner, there'll be your waste generator number, which typically starts with the letters ON and has 7 digits. And you need to keep a copy of this on site with you at all times. And the most important is your ECA for air, which is your certificate of approval for air. Concrete Ontario ran a webinar earlier about the requirements for the air, and Megan from BCX there explained the new requirements for air modeling as per Air Mod Schedule 3. Once again, you should keep your most recent or amended copy of your ECA on site with you. If you don't have access to that, you can get it from Access Environment, and the website is shown there. And the last thing we're looking for is if your facility operates at 20,000 employee hours per year, so that's approximately 10 full-time staff, then you have to assess under Environment Canada for what's called a National Pollutant Release Inventory, or NPRI, and this is typically done by your environmental consultant. So that ends the mandatory requirements. That has to be a pass in order to proceed to the Eco Gold portion. And now onto the Eco Gold, there's 4 sections here. And in each of these sections, you need a minimum score. You don't have to get 100%, but there's a minimum score, which I'll talk about after. So the first thing is your water use. So we want to see if the facility is able to quantify the annual potable water usage. So if you're on a well, you can get this from your well water results. If not, you can get this from your city water bills. So we want to know the total water used in your facility. So this is the water not just in concrete production, but used in other aspects in your facility, such as the washrooms, the kitchens, and all your washout. And we also want to know what your total cubic meters of concrete produced per year. And in this way, we can calculate what's called a water use ratio. So then get into the manufacturing process. Truck washdown after loading, you want to make sure that this water is directed and captured in a containment area, and to see if you're using recycled water in the washdown process. So the same thing applies to chemical washing at the trucks at the end of the day. We want to make sure that the chemical solution washing of trucks is directed and captured if you're using recycled water, and if the chemicals you're using are environmentally friendly. So some examples of environmentally friendly chemicals are long haul 305, liquid hammer, or chem station. If you're using acids such as muriatic acid or hydrochloric acid, these ones are not environmentally friendly, and we frown on those ones. So the next is your boiler blowdown. Again, we want to make sure that the blowdown water from your boiler is directed and captured and not seeping directly into the groundwater. If you're using slurry or processed water back in the manufacturing process, there's a series of tests that have to be done. So the first test is compressive strength testing. So this is conducted on a 25 MPa or greater concrete strength. And we want to make sure that the water used in that is greater than 90% of the strength of a water of known quality. You also have to do set time testing as per ASTM C403 and chemistry testing of the water. So the chemistry testing of the water is based on CSA 823.1 Table 9 requirements, which requires chlorides, sulfates, alkalis, and total solids to be tested. And this is only needed to be done if the owner requests it. So typically, if you're producing for an MTO projects and you're using slurry and processed water into the mix, the MTO would want to see your chemistry results. So for water conservation, Colin mentioned a few of these points before. We want to make sure that there's hose shutoff valves or timers are used for truck tank fill of your side tanks, just so that water is not overflowing everywhere in your site. We want to make sure that your employees are trained in water conservation, that you're using dry wash or multiple small volume rinses for drum washout, And you get a bonus point if you have a pressure washer on site, which is used to conserve water. So the last thing is your stormwater management. So we want to see if all stormwater flowing through the process area is captured and recycled. And when I say process area, I mean your washout pits, your material loading points, your slump racks, your batch points, and any other high pH levels. So in this section, there's a total of 10 to 14 points available. The minimum passing score in this section is 57%, or basically 8 out of the 14 points. So next we get into materials and resources. So we're looking for material reduction here. So does the facility have practices to reduce the total amount of potable water required to manufacture concrete? And this could be done by using water reducing admixtures or containing and recycling your slurry and wastewater. Does the facility have ways to reduce the total amount of new aggregates by using crushed aggregate or reclaimed aggregate back in the mix? And do you have options to reduce the carbon footprint by reducing the total amount of Portland cement? And this can be done by using supplementary cementing materials or GUL, which is Portland limestone cement. So on the delivery side, we want to make sure that the facility cleans the truck before leaving the facility. And at the job site, you're able to capture chute washout water. So either you can wash out into a contractor approved area or use an EnviroGuard or EnviroChute system on the back of your trucks. Next, we're looking for return concrete. We want to see what you're doing with your return concrete, if you're reclaiming the aggregates and reusing it, or if you're recycling it into blocks or crushing on site. Again, we want to see where you're storing your return concrete as well. So if you're storing this in your yard on a concrete pad, or you're just spreading it onto the ground, in this case, your washout solids are possibly contaminating the groundwater. So chemical management, we want to make sure that your chemicals have proper storage. So you got to make sure that each of your chemicals are on a separate containment, like the photo shown here. And that you have a spill kit on site, as Colin mentioned earlier in his, with the filters and the socks. So it's not just a bag of Absorbol and some rags, but you have to have the whole filter spill kit. And then some of the documentation we look for is if you have a spills response procedure or a spills prevention plan. And in this section, there is 14 to 16 points available. Minimum passing score is 60%, which is 10 out of the 16 points. So sticking with chemical storage, some of the chemicals we look at when we're walking through the yard is your gasoline, your diesel, both the clear and dyed diesel, waste oil and fuel oil if you have it, your bulk oils and your lubricants, your acids, your solvents, which includes your DEF for your diesel vehicles, your antifreeze windshield washer, and your concrete admixtures. So we want to make sure that these tanks are in good condition, that all these chemicals are impact protected, and that they're locked. We're looking for secondary containment for all your gasoline and your diesel. We want to make sure that you have control of all your chemicals on your site, and that all the tanks are clearly labeled and have the appropriate WMIS labels on it. In this section, there are 7 points available. The minimum passing score is 57%, which is 4 out of the 7 items. Okay, so next we get into error management. This one will be based on time. I might skip through error management because this was talked about at the last webinar that we hosted. So I'll just go through noise. Oliver, do we have time or should I skip?
You can do the last portion.
Yeah.
The 5. Yeah.
Okay, then I'll just skip over to number 5 because those other ones dealt with air. So the last one is innovation and design. So the last one is innovation and design. So does the facility promote environmental sustainability with suppliers of products and services? So some examples are just-in-time delivery for your materials. If you're buying your admixtures in bulk to minimize truck travel, if you're using plastic recyclable totes on site, or if you minimize travel delivery distances by purchasing your aggregate from a local quarry. We want to see if you work with suppliers now to drive innovation for product conservation. So a couple examples here: if you're using supplementary cementing materials, if you're using water reducing admixtures or reclaimed aggregate sources. Next, we look to see if you work with customers now to drive innovation for product conservation. So here, if you supply to lead projects or projects with a high volume supplementary cementing material, if you have an EnviroGuard or EnviroChute system for your trucks for washout, or if you're using GUL cement in this case. We want to see if the company promotes innovative technologies such as self-consolidating concrete for reduced labor or pervious pavement for stormwater management. We want to see if you have GPS for dispatch and delivery, so you're minimizing road congestion and driving distances. You get a bonus point here if you have LEED certified personnel on staff, or if you have any other innovative practices that are not mentioned within this checklist. So in this case, there's 6 points. You need a minimum passing score of 57%, which is 4 out of the 6 points. So that concludes the ECHO portion of the audit. The rest of the audit that we do deals with the concrete facility production, but I won't get into that today. I'll turn it back to Oliver for any questions.
Awesome. Thank you so much, Savio, for the overview of the environmental requirement for the plant audit program with Concrete Ontario. And as both Colin and Savio mentioned, we had our air requirement webinar some time ago, and recording and presentation is available on our website. You can just go to the webinar presentations and you'll be able to watch and find more information about the air requirement. Now back to the questions. Let me see. Okay, so as I mentioned, we will post the recording of this webinar and a copy of this presentation on our website, which you'll be able to access. Now, I have a question for Colin. So Colin, would you be able to share maybe some experience that you have dealing with different municipalities regarding the concrete chute washing water retention, on job sites? Any concern, any best practices that you'll be able to share with us?
Yeah, it's been kind of hit and miss all over the place. I mean, I've seen issues with it being, washed out, into a street or something like that, and that's definitely a spill and having to deal with that, or into a field, and then somebody complains about that. So I mean, it's definitely, we require, as Savio says, require the customers to have something on site where that it can be utilized and contained and that sort of thing. The chute wash systems, I saw a number of years ago, and we've recently, well, not recently, but in the last couple of years, really started to employ those. So I think they work quite well to contain, those solids and bring the water back into the truck to bring it back to the plant. So, I think it really depends on, what, where they're washing out to and where it's going. If it's, in a storm sewer or a wetland or something like that, or just a vacant field, or what kind of problems you might have. But it's the best thing you can do is contain it, and either with the system or something that's provided on site.
Great, thank you. Next question would you be able to provide kind of brief summary about the difference between municipal potable water source and water obtained from wells or surface water body? What's the difference, and also the extraction limit?
Delon, you want to?
Sure. I mean, municipal water sources for your water usage, that's just you've got metered water, you've got a utility that's providing you the water, and they're going to charge you with the water metering in the bill for the water. If you are on a well and you, like Colin indicated before, you're using the water there over 50,000 liters per day, you're required to have a permit to take water, and that's with the ministry. And if you're taking water from any other surface water, like a river, a creek, a wetland, a lake, a pond, again, that permit to take water applies. It's 50,000 liters per day or greater, and you go through a process. Now, there is a predetermined list of projects that pre-qualify under a shortened process called EASER, or Environmental Activity Sector Registry. So if you're between 50 and 400,000 liters per day, you can go through that process, but it has to be for certain conditions. So I'm not sure if water taking for concrete production would fall under EASER or not, but I think there's a long-term, so it probably doesn't.
You're correct, Dylan. I think Megan mentioned in our last webinar, ESOR is not applicable for regular concrete plants, batching plants.
Right.
But some volumetric mixer concrete producer might be able to qualify for that because we are producing concrete on the actual job site. Last question for Savio. Can you provide maybe a few commonly seen issues during your audit regarding water discharge or water runoff that you like to recommend, our member to be careful or take care of for the audit requirements?
Yeah, so as Colin mentioned, it's nice to see when plants are graded properly. So they're grading all their processed water back into a washout pit. I've been at some plants where I actually see runoff leaving their property, which is not good. And then corrective actions have to be taken. They have to dig a swale on one side or put a filter sock in order to contain this water. So that's one of the biggest issues with the water. We got to make sure that their trucks are being washed as close as possible to where your washout pit is, and all that water is running back into that area. Yeah. Usually all the plants are right at the batch point, it's graded back, so the water is flowing back into your containment area, which is good.
Awesome. Thank you, Savio. To respect everyone's time, I don't see any more questions from the audience. I would like to thank all our three speakers today, Colin, Dylan, and Savio, for your very detailed presentation on the water management side of the environmental requirements for the concrete production plants. Thank you again, everyone, for attending today's webinar. Please stay safe, and you will be able to access a recording in the near future on our website. Thank you.
Thanks.
Thank you. Bye.